Good morning or good afternoon, depending on where you're joining us. Thank you for joining this week's edition of Megaport Live. My name is Mike. I'm a solutions architect, and I will be walking you through a few different things related to Megaport today. Our products, we're going to do a little bit of slides and then some diagrams, and then we're going to get into our portal and talk about some specific use cases and build some things out. So with that in mind, let's get going. So Megaport has been around for several years, and we're a mature startup, as I like to say. And we initially focused our product on this port, which is a physical interface in a data center that connected via fiber optics, either through a last mile type of connection or from a cross connect directly from a cage present within a data center. And we'll talk a little bit more about this, but we're in almost 1,000 data centers worldwide. Megaport Cloud Router is a virtual construct based on compute. It is designed to go cloud to cloud, move workloads between clouds, etc. And again, it exists on compute locations uh, based all over the globe. And then Megaport Virtual Edge layers on that same concept of compute, but uses firewall routing and SD-WAN licenses that are deployed on compute and allows customers to have branch office type of connectivity. Uh, and it allows us to extend that to the cloud, other data centers, et cetera. We'll talk more about that. The way that we terminate those connections to the cloud or between Megaport endpoints is this virtual cross connect VXC. It's a layer 2 VLAN, and you'll see how easy that is to set up. We're really neutral. We pass whatever traffic's given to us, including IPsec, but it's a really easy way to provision services on our platform. Megaport Internet is available on our different access products from different locations around the globe. Very easy to stand up, comes with the /31 out of the gate. It does support BGP ranges as well. We also have Megaport IX or Mega IX in various locations around the globe providing 100% neutral internet exchange, right? The Megaport marketplace is intriguing in that we've got partners that publish on our marketplace, including different exchanges like uh, financial exchange as an example, and we can go into that. But you can actually get a service key from one of those providers and set up a private connection between your port and their port on Megaport. And it can be customers that you work with privately that you know are on Megaport, or it can be a company like Cisco that has a WebEx presence in our marketplace. And that service key is something that you can use provided from them, or you can actually give someone access to your Megaport, your resources by giving them a key that they can provision on their end. And you can put that in any Megaport endpoint that you desire. Okay. We have a global private backbone. You can stand up services in as little as 60 seconds. We are in North America, Europe, Asia Pac, and now South America. Hybrid cloud is a way for you to connect a port to multiple clouds, such as Google, Azure, AWS, Oracle. And this is what I was alluding to earlier. You can get that cross connect either directly in the data center or extend a last mile connection. And it is a physical interface on a Cisco device under the hood. And this is what it looks like in a slightly different way. So you've got the customer router uh, getting a connection through a carrier meet me room to a last mile connection through a carrier meet me room on the data center side. Get this cross connect, which you can download the LOA from our portal once you've established that port in a Megaport rack, and then you can build those layer 2 VXCs to the cloud as I'm showing here. Now this gets into that compute architecture that I was showing you earlier. So Megaport is in all of these data center locations, and by the way, enabled means we have a physical presence within the data center. Extended means we can get to that enabled location using data center providers, fibers such as a campus cross connect or a metro cross connect. So if you see that distinction, that's what we're talking about here. But when we, you know, uh, divide that into just what's compute enabled, which is MCR and MVE enabled, you'll see that the map shrinks a bit. But all of these compute locations are in key areas around the country. NFL cities is how I refer to them a lot. But they're in locations that are close to cloud on-ramps in major metros. And we did that obviously by design. So whether it's MCR or MVE, you can stand up close to where your branch offices are located. You can use the Megaport backbone to get in between all of these locations back to your ports and your data centers as well. right? So I live in Denver. That turns out here's an example of some compute locations in the Denver area, and you can see that they're enabled, and that's why you see this red flag. Cross cloud is that Megaport cloud router. The idea being that maybe I acquire a company and they're a Google shop, and I need to migrate some of that data into Azure. Well, by putting the MCR close to where those compute regions are, I can actually migrate from cloud to cloud without having to hairpin back to a data center. And we actually offer speeds from a gig all the way up to 100 gig. So very, very fast throughput. And it is something that you can use to tie back to a data center if you need to. But the most common use case is to get between clouds, either sharing or migrating workloads without having to hairpin all the way back to my data center. Okay. Now, virtual POP is a Megaport virtual edge. And again, router, firewall, and SD-WAN that you're seeing here, I get a license from a Palo, a Fortinet, a Cisco, a 6Wind, a VMware. I put it on the compute, and it allows me to use internet resources, mobile endpoints, and remote sites to get to the Megaport Virtual Edge, and then build those layer 2 VXCs to the cloud and public and private endpoints, such as the marketplace. These are some of the vendors we support. 6Wind, I'm going to highlight here in a little bit as it relates to a NAT use case. But the idea, again, compute networking plus the internet, and the MVE is the total cost of what you'll consume every month. Now, we actually have larger size all the way up to 1232 in terms of gig of RAM and also the number of cores. So exciting that we can offer even greater speeds. And the internet that we can add to that is from 20 meg up to 10 gig in increments of 1 gig, pardon me, of 1 meg. So here is an example of an MVE deployment tied to a port, in this case in Nebraska. I've got a Dallas MVE locations. I've got Chicago MVE locations, and I've got Northern California MVE locations. So in this example, what we're trying to show is I've got branch sites on the West Coast, branch sites in the Midwest, and I've got branch sites in the Southwest, Oklahoma and Texas. So I tie the branch sites back to a local MVE. They can talk to a port in my Dallas data center via VXC, but I can also use the Megaport backbone to build VXCs between these endpoints. So you can see I've got ports and I've got my MVEs, and we tie these together with predictable latency that we publish on our backbone. So once you get your hop to the Megaport Virtual Edge, you're going to use our backbone to get in between your resources. So a very nice way to regionalize, to compute, reduce latency, increase predictability. Now, Global WAN as a service is leveraging the Megaport backbone, which extends all over the world. And in this case, we're showing it as an MCR use case. But you're able to spin up the compute in Dallas, as an example, Ashburn, and Washington, right? Amsterdam, Singapore, Frankfurt, and Tokyo. And then you're building your layer 2 VXCs over our backbone between these, and it eliminates the need for MPLS. And it simplifies your deployment by bringing everything together on a single vendor. So this is an actual use case of a customer that I diagrammed out that based in North America and also in Europe. And they had an interesting situation where they had disparate MPLS networks through 2 different global providers. And what they wanted to be able to do was tie all of these together in a full meshed environment through ports. Again, this is a physical interface. In Denver, they actually have physical megaports connected, pardon me, to their cage presence. But in these other locations, they actually needed to get a last mile connection uh, in uh, in the I'm sorry, in Canada and also the UK and the United States in total. So what they did was they went to their MPLS provider and they said, providers, I should say, and said, look, I need to utilize my contract spend to get a last mile connection to Megaport's enabled data centers from these corporate locations. So it's an interesting way that they spun the spend, pardon me, and they were able to use that to get to us with a last mile and then fully mesh their environment using these layer 2 VXCs and then also connect to the cloud regions in Europe and North America. So a very simple way to completely combine the networks, retain your contractual obligations with an MPLS provider and really streamline your connectivity. So this is the neat example. So with that, I'm going to actually get out of here and let's spend a little bit of time talking through some more diagrams and just a really basic scenario. So again, customer router off of a customer location, dual last mile connections to dual Megaport ports. The reason that I brought this diagram up is that Megaport in many of our locations has what we call red and blue zone capability. So sometimes we'll perform a maintenance, and this gives us the ability to split those maintenances across red and blue zones. We'll never work on the same metro at the same time. So it's a good idea, and we do it as often as we can, where we split the design between the two zones. And then what we also do is create diverse VXCs, in this case for hosted connect or express route, and we route them to diverse routers on the cloud provider side. So this is a textbook example, dual last mile connection. This could be dual cross connects within a data center from a cage to dual ports. All right. We also offer something we call data center interconnect. Sometimes you'll hear us refer to the acronym of DCI, whether we should or not. But the idea here is that I have red and blue ports, and then tying them together are red and blue VXCs for redundancy. And again, we'll never work on red and blue in the same metro. So very common scenario, and very easy for you, by the way, to increase or decrease the speed of this connection of this VXC. They're highly elastic. They aren't burstable connections, but they are elastic in that you can scale them up and down. The one caveat I would say to that is that make sure that you establish, if you're on term, establish a floor. So what I mean by that is, let's say I've got dual 10 gig ports, but let's say I have seasonality and I want to be able to adjust that bandwidth. Well, what I would recommend is that you establish a floor of maybe 1, 2, or 5 gig. That would be the minimum that you would be under term for, but then you could increase it as demand requires. Right? With the Megaport cloud router, we often see it tied back to a port, but again, we also see it as just strictly cloud to cloud. So if I need to get from AWS US East 2 to central US, and I don't want to have to go back to my router in Chicago, I can actually just, or wherever this location is, but I can just go data center, cloud provider to cloud provider without having to go back through the data center. So this is a common deployment. Chicago and Ashburn as examples. Now, Megaport Virtual Edge, as we've mentioned, is router, firewall, or SD-WAN. These are my branch locations. I use IPsec SD-WAN to get to the MVE, and then we use an internet drain off the back of that to peer with the MVE. And then in this case, we're building connections to the cloud so that these branch locations can get to the Ashburn or Chicago area using Megaport, again, with that predictable latency. Now, one other use case that I want to highlight with Megaport Virtual Edge, one of the vendors that we support is actually 6Wind. And this is a really interesting use case where this particular customer needed millions of concurrent NAT sessions, network address translation sessions. And we were able to deploy 6Wind license on that 32 core, 128 gig of RAM. Okay. And this is ForceNAT, right? So public, and then it's translated to the private address, and then that's deployed via hosted connect to AWS or express route to Microsoft. And this is, something that is incredibly cost effective. You purchase the license through us, you install it on our compute, in this case, Chicago, and is a massive improvement and a massive savings as well. There's even a way this can be architected with a backup to go through a cloud provider's NAT. So if this is something that you're interested in, please bring it up with your account team. We'd love to talk with you more about it. Okay. Now, with that said, let's look at the Megaport portal and some of these different products that we're just kind of we're going to build out, and you'll see how easy it is to spin these up in relatively short order. So a port, again, that first access product is, I can spin that up, and let's talk in Denver. Let's go with Iron Mountain, and that's here in Denver. And by the way, Megaport is data center agnostic. You'll see on this list, I've got Center Square and Iron Mountain. We've got 123 net, 1623 Farnham. We've got 365 data centers, Equinix, CoreSite, Digital Realty. We have presence all over the globe. And one of the key values of Megaport is that if you're under contract with a certain data center provider, we can usually work with you without issue, but we also could connect you with other providers that you may or may not be under contract with. So definitely a huge benefit that we are agnostic. So again, let's look at Iron Mountain, and we'll just quickly spin up a port. So if I come in here and choose Iron Mountain, you'll see we have 1, 10, and 100 gig ports. Ones have largely been deprecated. We still have some. If you have one, we're not going to take it away. But the 1 and the 10 gig are actually the same price. So we generally recommend customers go ahead and go with the 10, and you'll see it 600 a month or 450 on a 3. And if I change this drop down to 10, the pricing stays the same. So generally speaking, we tell customers to go with 10 gig. What you'll notice when I click on 100 is that it becomes 4 times the amount of a 10 gig. So we have the ability to lag ports together, that is to bond them and create larger ports. So I have the ability to create a lag group, and I could do up to 8, but the break even cost wise is 4 times. So what I mean by that, if you're thinking I'm going to build a 40 gig lag and bond those together with 4 cross connects, great. But if I put in a 100 gig port, I already have the ability to have that ceiling to go up to 100, but I'm at the same price as 4 ports, and it's a single cross connect. There's a few variables that need to be included, like your SFPs and some other things. But when we're talking to people and we're talking about a design, if they think they're going to need greater than 40, then we'll go ahead and recommend 100 gig. Now, in many of the data centers, we do offer an automatic ability to provision. It does depend on the data center provider. But let's go ahead and just provision dual 10 gigs. And you can see I'm going to go ahead and create diverse pair. And then we'll just name this the second one. And that will create that red and blue zone. Now, one thing to notice, you'll see that I've got that red and blue, like what I was showing you on my diagram, but these are not HA per se, and they are not laggable, meaning if I create a red and a blue, I can't combine those together to create a single 20 gig port. The lags need to be in each zone, just for point of order there. So I've got those 2 ports. And now once I review the order and I hit submit order now, that will kick off the order. And within minutes, then there's the ability to download an LOA to give to the data center operator. And there may be a port that we've got here where there's one showing. Yeah, so this one was built in Salt Lake and Databank SLC2. And once I click download, I can download the LOA, give it to Databank. They can run that cross connect. That tends to be the longer, a process. Takes a couple of days, but normally they do it fairly quickly. But something that's immediately done in the portal. And we talk about provisioning in 60 seconds. That's what we mean. It's that easy to kick that off. Once we see, light on this port and it's green, then it's ready for traffic. So this is an MCR, and I'm going to deploy one. But when the MCR is green, it's ready to go for service. And in this case, this one was actually provisioned to cloud providers so they could move between Google and AWS. So let's just build an MCR really quick. So we'll go MCR. And let's build one in CH4, which is Equinix. And let's just see. Yeah, so we've got, in this instance, we've got up to 10, but we have 100. You know what? Let's do something really quick. Let's go back. And let's look at MCR, and let's look at Digital Realty and Chicago. There we go. Okay, that's what I was looking for. So in this particular locations, we have 1 to 100 gig capability, and we have red and blue zone diversity within the building and also Chicago Metro. So let's look at a 1 gig. Okay, and that's about 500 a month for 1 gig of total throughput. The AS number of this is 133,937. So if you're provisioning services to the cloud, this is basically your A-end AS. So just bear that in mind. This can be changed. You can make it whatever you want. but by default it's 133.937 for any Megaport cloud router. So you can see this one configured in the blue zone. I can add MCR, moves it into the shopping cart on this left-hand side. And if I went ahead and clicked order, it would start the process of building that out. So in the interest of time, we got about 10 minutes left. I want to show you what an MVE might look like. So I have one built that outlines the steps, but I want to walk through it so you can see what it looks like. So let me grab one piece really quick. Okay, bear with me 1 second. I'm going to grab an SSH key here. All right, so what we want to do is go in and create MVE. And you can see these are the various vendors that we support. I was talking about the 6Wind capability here that supports NAT at very high speeds. So we've got 6Wind, Aruba, Aviatrix, Cisco in what we call autonomous mode, or Cisco 8KV. That can be in SD-WAN or routing mode. We've got Cisco FTD. We've got Fortinet. We've got Meraki, which is in beta, closed beta. Palo Alto SD-WAN, Palo Alto Firewall. And then you'll also see we have Peplink, Versa, and then VMware SD-WAN as well. So VeloCloud, that's what this guy is here. All right. So let's grab this Palo here, this VM series. We'll go next. And let's just grab, since we're in Iron Mountain, let's grab Denver. And these are the different sizes that are available there. So let's grab this 2-core 8 gig of RAM version here. And you can see from a pricing perspective, on no term, it's about $840 a month. And then on 36, it's about $630. So if I click next, let me take this out here. Okay. I'm going to put a password in here. And then I'm going to drop my SSH key in here. All right. Now, here is where I can set up additional VNICs or sub interfaces. One we want to reserve for management to get to the box through an IP address that we'll assign, but I can actually add other VNICs to tie it back to an HA version. Maybe I want to have a prem that version of Palo that I want to tie it back to, and then also maybe I just want to keep an additional one just because. But the reason I'm showing you this is that we want to set up the 5 VNICs at the outset, even if we don't use them, because it leaves spares that we can add additional services to. So I'm going to click on next. And then I'm going to go ahead and click add MVE. And then what it's going to ask me to do is create my internet. And so this is the internet component that is going to allow us to access it via the management VNet. So the first thing I'm going to do is grab this one here, and you can see the internet's local to this same location where the MVE lives, and it's in Denver. And I'm just going to do a 20 meg, very low bandwidth connection from a management standpoint. And then I can add it to this management plane here. And just to call it out, I can call it management in the title. And we'll go ahead and add it on a 12-month term. Okay, and add VXC. And now what we're going to do is go ahead and add it for the data side, which means how those branch sites talk to this MVE and also how it talks to the cloud or a data center. And we'll go, pardon me, internet. We'll go grab a diverse provider. By the way, in all of our markets, we have diverse providers of internet. So I used, GTT in one, and I'll use Cogent in the other. And then I'm just going to name this data. And we're going to go ahead and do a full gig. We could do up to 10 if I wanted to. And I'm going to assign that to the data plane. Okay. And now that's ready to go. So there's the components are the MVE itself, the license cost of that per month, plus the internet. And then if I was provisioning a VXC to maybe a port or to this MCR, there would be a cost for that. And then if I was provisioning a VXC to the cloud, there would be a cost for that. I'm going to leave this in the shopping cart now because the process of spinning this MVE up actually takes a couple of minutes that I'm not going to spend on this call. But what I do want to show you is I have one that I created earlier, and it's got the management and data plane internet already set up. And so what I can do as an example is come in here and let me grab a service key here for an express route, and I'll show you how simple it is to set that up. All right, so prior to the call, what I did was I went in and created a an express route uh, to the West US compute region using Denver as an on-ramp. And what it does when you do that is it creates a service key for the express route. And so what I can do is come into here and hit plus connection from the MVE, and then I can choose cloud, and then I can scroll down and choose Microsoft. And I can paste that service key in. And what it'll do is show me the options of where I can provision that service. Okay. So what I'm going to do is split that over two different Azure routers. And the first one I'm going to do is red. And because it's very close to that Iron Mountain site, the milliseconds is less than 1 to get from Iron Mountain to Core Site where the on-ramp is. I click next. 50 meg is pre-populated because that's how I built it in the Azure portal. So it makes the API call back to Megaport. And so we'll just call this ER red. Okay, that's the red side that we're building first. We're going to assign that to the data plane. You can assign to VLAN if you want, or you can leave it blank. And then we're going to go ahead and provision this on Azure peering VLAN 200 and add VXC. But we're also going to add another one because we're going to split that express route into two. So I can use that express route key across two VXCs, which is their standard level of resiliency, which is recommended for their SLA on the Azure side. So we'll go in plus connection. We'll do cloud. Again, we'll scroll down to Microsoft, and we're going to paste that key back in. Now, this time we're going to go with the second one. I'm going to click next. All right, and we'll just call this ER blue. Keep it at 50 meg. We're going to assign it to the data plane. And we're going to do VLAN 201. Okay. And that's it. So once I click order, then these VXCs will be in place. And from the MVE, then I'll have two connections back to, let's show this. It'll look a bit like this, right? So I've got a connection here, and I can split it red and blue to the Azure Express route. So I want to ask, is there any questions in chat?
No questions today.
Okay. Well, thank you for that. Thank you all for joining. I hope you have a fantastic weekend, and we'll talk to you next time.